Thank you for coming to hear about monads. So my name's Carin Meier, and I work for EdgeCase, and I love stories. So I read stories to my kids. Stories teach us. Stories entertain us. In fact, stories, I heard in the news the other day, can even help us with problem solving. Problem solving is actually increased when you present the problem in the context of a story rather than just thinking about the problem itself. So with this as my background, this is not just going to be a talk about monads. This is going to be a story about monads. And our story begins with Alice. Alice is a computer developer. She's been developing software for quite a number of years, and she's been happy living in the lands of objects. She loves objects, she makes objects, she modifies objects, she takes these objects and puts them together to make large things and small things. And in fact, she's so comfortable with objects that when she looks at the world around her, she just can't think of another way that you could model it other than using objects. And she was pretty happy until one day she met Clojure. And Clojure rocked her world. It got her out of this object-oriented box, and she saw this new wonderful vista of functional programming. And she fell in love. She started reading books about Clojure. She started reading blog posts about Clojure. She started following people on Twitter that talked about Clojure. And one day, when she was reading a blog post about Clojure, of course, she came across a very strange word, monad. She let it go this time. She was interested about Clojure, and she wasn't going to worry about this. So she went on her merry way, reading more blog posts. And again, monad. It just kept cropping up over and over again. She'd read some more, and again, monad. And again, monad. What the heck is this monad? So she figured she could do what only about every one of us would do, is she decided that she was going to take on her lunch break and actually grab a coffee and read through Wikipedia and some blog posts on monads and figure out what this stuff was. So she did that. She went to the coffee shop, she sat down, devoted a whole hour, read Wikipedia, read the blog post. At the end of the lunch, she had no idea still what monads were. So she decided, I'm not giving up. It cannot get to me this easily. I just need to devote more time. Instead of lunch, I'm going to devote a whole evening. And she set herself up for success by making sure she had a nice plate of cheese. Oh, goodness. My resolution. Okay, we'll see if it will work. She had a nice plate of cheese and some crackers and some wine. And it was a cold night, so she had to make sure that there was a nice fire in the fireplace. And she sat in her comfy chair next to her favorite books. So she's ready. She's going to devote a whole evening to monads. She's got her books, she's got her cheese, she's got her fire, and she's got one other important thing, and this is Philip Wadler's papers. She's going to look at two of them, which is one is Comprehending Monads, and the other is Monads for Functional Programming. And so she sits down, and she's sitting by the fire, and she's eating her cheese and crackers. And the first thing that she notices, that not only is his papers brilliant on monads, but they're also in poetry. There's poetry in them. So the first line in Monads for Functional Programming, it begins with, shall I be pure or impure? I mean, this is poetry. And not only is it poetry, it explains beautifully the two communities in functional programming. There is the pure functional programming side, and then there's the impure functional programming side. On the pure side, of course, you have all the benefits of equational reasoning, which allow us to have lazy valuation. But then again, on the impure side, you get very practical things that are very handy, such as state, error handling, and input-output, and basically side effects. And pure languages, of course, are Haskell, and impure ones are our favorite, Clojure and Scheme. So Wadler goes on to give us another piece of poetry is there a way to combine the indulgences of impurity and the blessings of purity? So, in other words, is there a way that we could have our cake and eat it too? So enter Engenio Moggi. I hope I pronounced that right, but he's a computer scientist from Italy, and he did some work with functional programming, and he actually found a way, he proposed a way of structuring semantics to describe state exceptions and etc. side effects in programming. And he did this using an abstract branch of mathematics in category theory called monads. So what are these monads in category theory? Well, they're also known as Clojure triples, or triple, and it's an endofunctor together with two natural transformations. And it's used in theory a pair of adjoint functions. So Alice thought about this, and it didn't quite sink in as she would have hoped. So she took another bite of cheese, another sip of wine, and she sat by the fire, and her toes were feeling quite warm, and she just decided just to close her eyes just for a moment, and maybe this would somehow sink in. So she closed her eyes, and she was suddenly awakened by her phone going off. And it had a strange picture of a rabbit on there, which was not there before. And it got even stranger, because the next thing she saw was a message saying you were late. Even stranger than this, it said she was late for a monad symposium in 15 minutes. So she looked around. She still seemed to be in her chair by the fire with her plate of cheese. But she heard something rustle, kind of running past and going down the cat door in her basement. So she had to get up and investigate. So she went to the door to her basement and opened it up and started going down the stairs. And the stairs actually seemed much bigger than they normally did. And all of a sudden, she started seeing strange things on the wall. It almost looked like formulas. So she kept going down a little bit more. And another thing would pop up. It was very, very odd. She kept going down the stairs a little bit more. This was getting very strange. And in fact, the stairs were going on a lot longer than she had remembered the staircase. And in fact, it seemed like a cartoon, because she finally looked down at the stairs and realized there weren't any more stairs there at all, and she just started falling. So she fell until she landed quite softly, nicely, into a room that just had a really big door. There was no way that she could reach the handle of this door. There was nothing in it, no tables, no chairs, nothing. She had no clue what to do next. In fact, the only thing that could give her a shred of hope was a little piece of paper that said, "Say hello" on it. So she tried it. She looked at the door and said, "Hello." And the door answered her back, but with a question. Is it true that this could be a monadic return operation? Okay. Let me see. Defining a function return takes a parameter of a value, and it returns that value back in a function. Let's see this in action. So if I would just call this on a string, say jelly, it would give me back a function. And in Clojure, of course, we can execute functions by putting this in another set of parens. So if we execute return jelly, it'll give us jelly. So she really didn't know whether this was or not, but she had a 50-50 chance, so she said, sure. And the door said yes, because the return object is a function, which is a container or monadic value, that when executed is jelly. Okay. So the door asked her another question. Is it true that this could be a monadic return operation? Okay, this is labeled return as before, and it takes a value, but it doesn't do anything to it. It just returns back that value. I'm suspicious. So if we just give it a string, no. Because the return object jelly is not a function and a container or a monadic value. Okay. The door asked another question. is it true that this could be a monadic bind operation? Let me see. So if we call bind with a monadic value in a function, and we take this monadic value and we execute it, we get the value back, so we apply the function to it. Maybe, let's see this in action. So if we defined a function called with toast, and it takes a string, and then it returns back that string concatenated with toast and we execute it, and we put it in the bind. So we say bind, and we have to do return jelly to make a monadic value, and then we say with toast for our function. It gives us back a container or a monadic value, but if we do that paren trick on it again, we'll get back toast and jelly. So it applied that function to it. So again, Alice wasn't too sure, but this felt kind of good, so she said yes. The door looked pleased. Said yes, because it takes a monadic value and it applies a function and it returns a monadic value. Well, this was all very interesting to Alice, but she still didn't see how it was going to get her farther in opening the door. So she started looking very perplexed and upset about this, and the door noticed and started asking her a more pointed question. Can you write a monadic return function for yourself? Alice thought. Well, if I define me to be a string, I could write return me, and it would be a monadic value, and then I could execute it, and it would be me. The door said, good. Well, he didn't say good, but you could tell. He said, can you write a function that makes you grow and returns a monadic value? Okay, so we have a return function for myself. We could define a function that takes a string, and it kind of cheats, but it's going to take the last character from that string and concatenate it to it. So when we call grow me, it's going to be a monadic value, of course. And when we execute it, it's going to be me with an extra E on the end. So we're growing the string, and we're growing ourselves. So the door said, good. So now can you use this monadic bind operation to grow? So let's define another function called mgrow. So it's going to take a monadic value, and it's going to use this bind on the monadic value and grow. So here, we have to start off with the monadic value return me. So we call mgrow on that. It returns a monadic value. And if we execute it, again, with the extra parens, it turns off me with the extra E. Alice looked pretty pleased at this. And the door said, good. Well, now grow bigger. Let's chain these. So she chained it 3 times, and she ended up growing quite a bit. And there's another way we can write this. It's a little bit more aesthetically pleasing in Clojure, using a macro, the threading macro. So we can say return me and do 3 mgrows. And it's the same thing. We'd get back me. So the door was looking very pleased indeed. And Alice grew, and she was able to open the door. So the next scene she came into was this wonderful forest glen. There was a nice path, and she figured, well, she might as well try to find this monad symposium. So she wandered down the path for a bit. Beautiful trees everywhere, and the path went straight for a while, and then it forked. There's a path either right or left, and she didn't really know which way to go. There was a tree right in the middle of the path, and she stood there for a minute contemplating which direction might be the best way to go. And as she stood there, she heard a rustling in the tree, and she looked up, and there was a smiling cat there in the tree. So she did whatever you would do if there was a smiling cat in the tree. She decided to ask it for directions. So, Mr. Smiling Cat, would you please tell me which way it is to the Monad Symposium? The Smiling Cat said, you want directions. To have directions, you have to have where you are and a destination, and then you can have directions. You obviously know where you want to go, but the problem is you don't really know where you are, do you? So if you have a function like this, which take a parameter where you are starting, directions. Let's see. is kind of a silly function, but it'll do for just explaining it. If we had start as a string, we could concatenate that with a random right or left and return that wrapped in a monadic value. So we could then define m directions that takes a monadic value and binds that to this function directions. So if you started with here, the string here, and you wrapped it in the return function, of course, and then you called a couple directions on it, you would start with here, you'd end up with here and right or left. Since it's random, it could have been right or right, but just for the sake of argument, we're doing right and left. So the problem with this is that if you don't know where you are and you start off with a nil, it just blows up with a null pointer exception. So the cat said, can you think of any way you can get around this and fix it? So Alice sat there and thought for a moment. And she said, let me see. If we took this bind function and if we modified it slightly, we could take this monadic value when it comes in and get the value out of it, and then we could check to see if it was nil. So if it was nil, we can just return that the monadic value of nil. But if it wasn't nil, we can apply the function to it. So that might work. So she tried it, and it did work. It turned nil instead of blowing up. The cat smiled even bigger this time and said, that way. So she thanked the cat very nicely for showing her the directions. And as she watched, the cat slowly disappeared and left only a pair of parens. So she headed down the way the cat had indicated, down the path. And there was a little bit that she had to walk, and suddenly she entered a clearing, a forest clearing, and there was this beautiful tea set up, all silver, place settings for 8. But the only problem is there was only one person there, and that person was dressed in an astronaut suit. And if this wasn't strange enough, there was nothing else on the table but a burrito. So Alice was very confused, and she didn't know what to say next when the astronaut came up to her saying, you're finally here. You are so late. We are going to have to cancel the whole monad symposium. Please get started immediately. Well, Alice didn't know what to make of this. She said, I'm sorry, there must have been some sort of mistake. I was just here to see a monad symposium. Definitely, I have nothing to do or present. He said, oh dear, it's quite natural to have nervous jitters. I'll help you get started. Let's sit down and you can say this together with me. Monads are like astronauts. Alice said, I'm not seeing it. I'm sorry. So the astronaut said, okay, maybe we should start with something simpler. Let's try saying this with me. Monads are like burritos. Alice said, I'm sorry, you're confusing me. I don't really know what you're talking about. And then she said, oh, I think you're referring to some blog posts that were comparing monads to astronauts and burritos. Oh, yeah, I tried to read those, but I'm afraid they only got me more confused. I don't think this is the right way to go about it at all. I'm afraid at this, the astronaut sat down at the table. He took off his helmet, and his face was bright red. He was very exasperated. He said, fine. If you don't want to talk about astronauts, spacesuits, or burritos, why don't you just sit down and have some tea? Maybe you could do something useful, like tell us how many cubes of sugar there are as we go around and drink our tea. She thought about this and said, well, at least it's a problem. We can work with this. So we can make a function for having t. Let's call it MT. And it would take some parameters. It would take a monadic value, and it's also going to take a little extra. It's going to take the name of the person having t. So we're going to have 2 parameters this time. So we're going to use our bind function, of course, on the monadic value, but this time we're just going to actually define the function in here, and we're going to return the string of the value concatenated with the name of the person having t. So let's see this in action. So if we start off as me having t, and then we call it MTU, then it's going to return the string me and you. So we might have to also change this return function slightly so we can accommodate this state of the sugar cubes that we're starting out with. So instead of having just a value that we're returning wrapped, we're going to return a function of the state with a vector of the value and the state. So a little bit of a change. But if we're modifying the return, then we also have to modify the bind. So this monadic value, we're going to now destructure into a, here we go, it's a value and the state new. So remember, we have to get the value, we have to give it a state, and then we're going to get the answer back here. And then once we get the answer back, we can apply the function to this value, and then we have a new state, and we can wrap this all in a function of the state. So this is now what we're going to be returning. So let's see some examples of this. So the nice thing is we don't have to change this MT function at all. But if we start off with me, and we call it MTU, then we also start off with 10 sugar cubes. We're going to end up with me and you and 10. So we know we have 10 sugar cubes. Okay, this is good. We have state in here. Now we can do something with it. We can actually track the sugar cubes. So if we define a take sugar function that takes a monadic value, what we could do is bind that monadic value to something that modifies the state. So it's going to take the value, but here's the important part. It's going to decrement the state before passing it back. So let's see some examples in this. So this actually should be kind of on one line here, but we could say return me. So I have t, and then I take a sugar cube, and then you have t. We start off with 10 sugar cubes, and we execute this. We're going to end up with me and you and 9 sugar cubes. Very cool. So let's try this again. We start off with me, take 2 sugar cubes, and then you have t. We start off with 10. Then we're going to end up with me and you 8. So she felt very pleased. They could have tea, and she could figure out how many sugar cubes were used during the tea. So she looked over at the astronaut who now had his helmet off, and he seemed to be much happier. And he even offered her a cup of tea, which she kindly accepted. And she actually felt kind of pleased with herself. And as she was drinking the tea, the room started spinning. And as it started spinning, she realized that she had actually been implementing monads during this whole time. At the door, she had implemented the identity monad. So, and the important stuff here is in the return and the bind. You can see that all it was really doing was applying a function to the value. So she had this function that made her grow, and all it did was apply that function over and over again. It made the e's grow on there. And then at the tree with the cat, she had actually implemented the maybe monad. And again, you can kind of look in the return and the bind to see what's happening here. That she checked the value to see that if it was nil or not. If it was nil, she returned the nil wrapped, and if it wasn't nil, she went ahead and applied the function. So she did some error handling here. And at the tea party, she had implemented the state monad. So it's a little bit more complex here, but you can still see what's going on when you look at the return and the bind, that there is a new state, and this is a function of the state, and the bind is keeping track of it as well. So in his take sugar function, she decremented the state so that she could keep track of it and modify it. So very cool. And all these examples had some things in common. The 3 monad laws. So 2 of these laws have to do with this return acting as a neutral element of bind. So it's kind of complicated when you look at that in the rule. So if we see some examples here. So if you do return me and then we bind it to grow, it applies that function. So it makes the me grow. And same thing, if you just call the grow on me, it does the same thing. So that takes care of the left unit, which is the first monad law. So the second law has to do with the other side, which is the right unit. And you've got, well, it's easier to see an example, that if you call the bind on the return me and then you use this return function, it's just going to return the thing that you started out with. And the same thing is if you call return me and execute it, of course, then you end up with the me. So that's the 2 monad laws that kind of deal with the same thing. Now the third monad law is a little bit more complicated. It's the associative law. And it just talks about the ordering, really, of things. That if you binding 2 functions in succession is the same as binding 1 function that can be determined from them. So here, if you call a couple binds and a couple grows, it's going to expand the me. And that's the same thing that if you would call the bind on the return me and then put it in a function that's doing the same thing. So just an ordering. So Alice was reflecting on all this as she was kind of spinning around and thinking about the monad laws and thinking about all the monads she's implemented. And she heard kind of a beeping a little bit far away. And the beeping got a little bit louder and a little bit louder. It was her phone again. For a minute she thought it looked like a rabbit, but then it went back to her normal phone. And she looked around and she was back in her chair by the fire and by her cheese and by the books. And she thought, wow, that was the weirdest dream I have ever had. I should watch the cheese. So, in summary, we saw 3 types of monads that we implemented. There are many more types of monads. There are IO monads, collections monads, continuation, writer monads, etc., etc. And they all obey the monad laws. So, just so you know, we've just scratched the surface here. Monads are all about having your cake and eating it too. So you can have these pure functions and pure functional languages, and you can keep all the messy and impure stuff on the outside. So it's a way of structuring your programs. So some practical uses of monads. They're very useful when you have things in kind of a pipeline in sequential execution. Examples of this would be parsing, fuzzing, web request processing. They're also very useful for reusable modular side effect processing. Like if you have things where you want to do error handling again and again and logging, and you can kind of use them as modules as you go along in your pipeline. And they also allow you to keep your business logic clean and pure in your functions and do all your side effecty kind of things that you want to do outside of that. And the most important thing is to use caution when mixing monads and cheese. So resources. When I was learning about monads, Philip Wadler's papers are great. They're a little bit heavy reading. I highly recommend them. Adam Smychek, he's got a video, and I have a fondness for him because it was the first video I watched. I was like, oh yeah, I think I get this. And a lot of my examples follow from some of the examples that he gave although he didn't really have a lot of the cheese in it. So. And Jim Dewey, he's got a great series of blog posts on monads and Clojure. He's done a series for Clojure West that actually some of the monad laws I took from his examples. Very good. And there's a Clojure library, Clojure Algo Monads by Conrad Hinson, that is a very useful library. And he actually goes through a lot of good examples in his documentation blog post about monads as well. You can check out. So that's all that I have.